Hey guys, I'm here back with another math video. Today we're going to be doing a relatively simple logarithm problem. This is from Mandelbrot, um, Mandelbrot Nationals, round 5, question 5, 2008 to 2009. So look at the problem if you need to, pause the video, and we'll go on to the solution. So in order for these three numbers to be in an arithmetic progression, that means the differences between these numbers must obviously be the same. So we can simplify that into, simplify that into log base 8, 7x plus 8, minus log base 4, 3x plus 4, is equal to log base 4, 3x plus 4, minus log plus 2 plus 2. And then we can move this to that side and put the log base 4s on the same side. And then we get log base 8, 7x plus 8 plus log base 2, x plus 2 equals 2 log base 4, 3x plus 4. Which is, cool and stuff, but let's see if we can simplify that down further. Now, one of the main problems with this expression is that we have logs that are of different bases, and we want to make them all the same base. So, one of the rules of logs, we notice that all the bases here are powers of 2. So one of the rules of logs is that if you have log base x to the y of some mx plus b or some expression, then this is equivalent to 1 over y log base x plus b. And using that rule, we can simplify this down into 1/3 log base 2, since 2 to the power of 3 equals 8. So we can just take that power out and make it divide the log over that, and do this plus log base 2 x plus 2, and then we divide this by 2, since 4 is 2 to the power of 2, and then we can just get log base 2 3x plus 4, since you divide it by 2, and then that takes out this thing. So we have this. What do we do next? So from here we can actually just get rid of the logs outright. So first we can make this log base 2. You can take the coefficient and make it the power. That's one of the rules of logs that we reviewed in an earlier video. So cube root of this, and then if you add two logs together that of the same base, you can multiply the expressions within the logs together. X plus 2 equals log base 2 3x plus 4. And then we can cube both sides to get 7x plus 8. We can take out the logs because it's log base 2 on both sides. We can combine them both into a single log. Then we can cube both sides after we take those logs out. And we get 4. That's slightly simpler. I think this just looks like a polynomial, and I think the polynomial we get is x4 plus 23 x cubed plus 24 x squared plus 8x equals 0. And this can simplify into, if you just like guess and check a possible root, you first divide the whole thing by x, and then one of the roots is -1. So this actually simplifies into 7x squared plus 16x plus 8. I just realized I wrote outside of the boundary. I'm sorry about that. I have a new video recording software, so that's just mx plus b. That's what's supposed to be there. Yeah. Okay, so the only irrational value of x having this property. So, uh, -1 is not irrational, so we'll take this and look for an irrational thing. And of course, everyone knows that the quadratic formula is -b plus minus b squared minus 4ac over 2a, unless I like forgot it. I don't think I forgot it. That's right, right? Okay, good. Well, after you put that in, after you plug all the numbers in, you get I think it's 17 -8 plus minus 2 square root 2. That should work, I think. Yeah, so you have like two irrational solutions here, and that won't really work considering like they say there's only supposed to be one. So the reason that doesn't work is because you need the logs to be positive. So we have like our original expressions up here, log 2, log 4, all these expressions. All of them need to be positive, right? Like 7x plus 8 needs to be positive, x plus 2. What's inside the logs needs to be positive, or else those expressions won't be defined. So actually, if you have a 1/7 -8 minus 2 square root 2, then log base, I think it's base 2 7x plus 8 is not real. I think that's what it is. So yeah, the thing in here will be negative, so it won't work. So we only have one solution left, which is 1/7 -8 plus 2. Okay, thanks for watching. I hope you guys have a good week.